This is practice problem number 1 from Lesson 3, Balanced Moves, and Unit 4, Linear Equations and Linear Systems. And this is a revised version of practice problem number 1. In problem number 1, you're given this hanger, and each triangle is an x, and each square is a y. And you're asked to write an equation for the hanger and solve for the value of a square or the value of y, given that each triangle is equal to 6 units. So each triangle is an x and each square is a y. And the number in front of the variable, x or y, is called the coefficient. It tells you how many of that variable you have. So I have 1x on the left side and I have 3 y's on the left side. So the 1 and the 3 are the coefficients. And on the right side, I have 4 x's and 1 y. Now I can rewrite this. I can drop the 1 because 1x is the same as x. So I have x plus 3y equals 4x plus y. Now the way that we solved this before with this balanced hanger is we removed a y from this side and 1 y from this side. So we had 2 y's is equal to, and we removed an x from this side and an x from this side. So we had 2 y's is equal to 3 x's. And you're going to see that in just a moment in the equation. So this is making a connection between this balanced hanger and this equation down here. So here's that same equation, x plus 3y equals 4x plus y. And we're going to replace x with 6. We could simplify this first. We could combine the like terms before we replace x with the value of 6. But in this case, I replaced x with 6 before I combined the like terms. So we have 1x, that's 6, and we have 4 x's. So that's 4 of these 6's. So 4 times 6 is 24. So now we have 6 plus 3y equals 24, because that's 4 of the x's, or 4 times 6 is 24, plus 1y. So now we want to get all the y's together on one side of the equation, all the x's together on the other side of the equation, so we can get down to y equals what value. So I'm going to add a negative y to this side and a negative y to this side to get rid of this y right here, because this y plus its additive inverse equals 0. So you're left with 6 plus 2y. So this is adding negative y plus 3y is 2y. This is like taking away a y on the right side and a y on the left side. So now we have 2y plus x. We have 2y plus x, or 6, equals 24 on this side. We took this y away. We have 4 x's. 4 times 6 is 24. So we have 24 on this side. So now I want to get rid of the 6 on the left side. That's like getting rid of this x. So I'm going to add negative 6 to the left side, because 6 plus negative 6 equals 0. I'm going to be left with 2y equals 24 plus negative 6. Well, 24 plus negative 6 is 18. So that's 3 x's. So now I have 2y equals 3 x's. So I have 2y equals 3 x's, because I've gotten rid of a y on both sides, and I've gotten rid of an x on both sides. And each x equals 6, so 3 times 6 is 18. Now if 2y equals 18, then half of 2 is 1y, so I'm going to multiply by the multiplicative inverse. So half of 2y is going to equal half of 18, and half of 18 is 9. Back here we had 2y equals 3x. Y was equal to 3 halves x. Well, if x is 6, then 3 halves of 6 is equal to 9 also. So think about that and write that out. 3 halves of 6 is equal to 9, and 2y equals 3x, so y equals 3 halves of x. Once again, x equals 6, so 3 halves of 6 equals 9.